In this video, we're going to look at the addition and subtraction of rational expressions that have different denominators. All right. And so this is going to be a little bit more complicated because, of course, this is going to be very related to when we have fractions that have different denominators. Let's review how we solve those. For instance, if we had 2/3 plus 1/6, or let's do 1/6 is fine. 1/5. Let's do 1/5. All right. In order for us to add these, we have to make sure that these are like denominators, right? So what we're going to have to do first is we're going to have to look at the denominators, the 3 and the 5, and then we're going to have to find the lowest common denominator. Now, for those of you who may have forgotten, the lowest common denominator is the lowest common multiple between the two numbers that are in our denominator. For instance, if I think about the multiples of 3, 6, 9, 12, 15, 18, 21, so on and so forth. Those are the multiples of 3. The multiples of 5, 10, 15, 20, 25, so on and so forth. And so if I want to look and find the least common multiple, well, look at the multiples that they have in common. 15, and that's the smallest one on both lists that they have in common. So my least common multiple would be 15. What we normally call that is the least common denominator. Okay, so our goal would be to rewrite these as equivalent fractions with 15 in the denominator, since 15 is our least common denominator, least common multiple. And so what I have to do, in order to make sure I have equivalent fractions, I have to think about what I multiply each of these by to get 15, each of these denominators. For instance, I'd have to multiply 3 by 5 to get 15 in this denominator here. So I'm going to have to multiply the numerator also by 5. And so that numerator is now going to be 10. All right, so 2/3 is the same thing as 10 over 15. Likewise, we do the same thing with this 1/5. I multiply 5 by 3 to get this 15 here. And if I do it in the denominator, I have to do it in the numerator because that'll be the same thing as multiplying by 1. 3 over 3 is 1. 5 over 5 here is 1. And so the numerator of that fraction would be 3 over 15. And so now that we have the same denominator, it's exactly the same as before when we add or subtract when we have the same denominator. You add the numerators. I'm going to add the 10 and the 3 to give me 13. I'm going to keep my same denominator, and then I'll simplify if possible. In this case, I can't simplify. All right, and so that's what we're going to do here. All right, some steps when we have these rational expressions, of course, is going to be a little bit more complicated when we talk about variables, but we go through the same process. We find the LCD, we rewrite as equivalent rational expressions. Didn't mean to mark through that, but equivalent rational expressions. And when I say equivalent, meaning I have to multiply the top and the bottom by the same thing, just as I did here and just as I did here. All right. Get those equivalent rational expressions with the LCD as the denominator, and then add or subtract, which we already know how to do. Let's look at an example. Before we actually get to an example, we need to figure out how we can find the LCD. All right. This is what we're going to do when we're finding the LCD of rational expressions. First of all, if I'm talking about multiples, I'm talking about things that multiply, right? So I'm going to have to factor so I can get my denominator in multiplied form, factored form. So that's the first thing. My LCD is the factors that are in one or both of the denominators, or all 3 of the denominators if I have 3 denominators. All right, let's look at how we can find our LCD. Okay, so these 2 examples, we're not adding or subtracting. The only thing we're going to do is find the LCD. I have 10 over 9 r squared s squared and 1 over 12 r s to the 6th. All right, first thing I'm going to look for is my least common multiple or denominator when I'm looking just at my numbers, okay, because I think that's a little bit easier. All right. Well, between 9 and 12, if I count by 9s and if I count by 12s, my lowest common denominator or my lowest common multiple is going to be 36. Okay. Now we're going to move on to r squared and this r right here. The things that multiply to give me an r squared are r times r. Okay. The things that multiply to give me r is just r. Okay. So when I think about my least common multiple, all right, something that I can multiply, I always have to actually take the smallest power. Sorry, the largest power. Always take the largest power because you need a multiple of r squared and a multiple of r. If my LCD was just r, then I couldn't rewrite this as just r without doing some other mathematics that we hadn't even gotten to. So I always take the largest power. So when I look at r squared and r, my LCD is going to have an r squared in it. So I got 36 times r squared so far. And since now we know that rule that we take the highest exponent, and when I look at s squared and s to the 6th, of course we're going to take s to the 6th power. All right, always remember that. Always take the highest power to put in your least common multiple. Okay? I know it has the word least in it, but we are taking the highest power because it is the least common multiple. Let's look at part B. Again, we have to factor those denominators first. In this example here, since that was already multiplied, it's already in factor form. There's nothing we can do to factor. But in this example here, we can definitely factor. So I'm going to factor this denominator into an x minus 8 times an x plus 3. All right. And this numerator here, this denominator over here has a difference of squares, x plus 8 times x minus 8. So when I look at my least common denominator, my LCD, I'm going to look at the factors that they have that's in one or both, all right? For instance, if I look at this x minus 8, it's actually in both of my denominators. So when I write my LCD, I only have to write it one time, all right? Now I have to look at the other factors in my denominators. For instance, this x plus 3 and that x plus 8 right there. Those are not in both, but they're in one of them, so they have to go in the LCD. So if I were to add or subtract, before I could add or subtract these two, I would have to have the LCD x minus 8 times x plus 3 times x plus 8. Let's actually look at an example where we actually do the addition or subtraction. All right, this example right here, it just says to add these two rational expressions. All right, if I look at my denominators, they can't be factored at all, right? So I'm at a good point to find my LCD. Well, my only denominator here is x minus 5. My only denominator here is x plus 7. Remember, it's got to be in multiplication or factor form, and it's already in that form. And so when our denominators are different, we just multiply them to get our LCD. And so my LCD is going to be x minus 5 times x plus 7. And so my goal is to rewrite these two rational expressions as equivalent rational expressions with my LCD in the denominator. Well, since our denominators are changing, that means our numerators are going to change. All right. Now, in this example, I'm starting out with an x minus 5, and I'm going to have an x minus 5 times an x plus 7. That's the one that's not in my original. So if I multiply here on the bottom, I have to multiply it on the top. So this is going to give me a 4 times an x plus 7 on my numerator. Okay, so I multiply the top and the bottom by x plus 7. Coming to the second rational expression, I have the x plus 7 in my denominator on my equivalent fraction, but I don't have the x minus 5 from the original. And so if I multiply it here on the denominator, I have to multiply it up here in my numerator. So I'm going to have a 3 times an x minus 5. Now we're at the point where we can do some simplifying. All right. I'm going to go ahead and multiply or use my distributive property. And since I now have a common denominator, I don't have to separate these things. I can go ahead and write it as one fraction doing my addition. This is going to be a 4x plus 28 plus a 3x minus 15. And the rest is just simplifying. I have a 4x and a 3x, which gives me a 7x. And a 28 minus 15, which gives me a 13 over x minus 5 times x plus 7. Okay? Now, what I would do now, since I have everything combined, I will see if I can factor my numerator. But my numerator can't be factored, so this would be considered my final answer. This would be considered my final answer. It's a single fraction. Nothing can be simplified. I know I'm done. Let's look at this next example. A little more complicated. Okay, we have these two denominators that are not the same. And so what we're going to do first, once again, is we're going to factor our denominators. X here, a minus 5, and a minus 4 will work for us. We have subtraction this time, so we're going to have to be careful. Again, I'm going to factor actually. I factor and I get these two denominators here. Now, I'm at a point where I can find my lowest common denominator, my LCD. First, I always look at what they have in common, which is the x minus 5. So I know that's going to go in my lowest common denominator. And then I look at what they have not in common or uncommon. That's uncommon between those two. And it includes the x minus 4 and the x minus 6. And so if I want to subtract, then I'm going to have to rewrite these as equivalent fractions with that LCD in the denominator. So I'm going to have x minus 5 times x minus 4 times x minus 6. Keep my subtraction symbol. X minus 5 times x minus 4 times x minus 6. All right, now we got to look and see what we have here. In this first denominator, right, we started out having the x minus 5 and the x minus 4. We don't have the x minus 6. So what I'm going to have to do is take that x that's in my numerator and multiply it by the x minus 6. Okay. All right, so I multiply this top and this bottom by x minus 6. Okay. Same thing as multiplying by 1. That's why it's legal. In my second rational expression, we have the x minus 5 and we have the x minus 6, but we don't have the x minus 4 in the original. So what we're going to have to do is we're going to have to multiply the top by the x minus 4 that we're missing, right? Because we multiplied the top by x minus 4 and the bottom by x minus 4. Now I'm actually going to simplify before I do my combining of my fractions, only because I have a subtraction here. I don't want to mess anything up too bad. All right, so when I distribute, I get an x squared minus 6x. And I know this is a lot of writing. Minus a 5x minus 20 over my LCD. And now that I have rewritten these, I'm going to write these as one fraction, one rational expression. But I'm going to have to be very careful when I do this subtraction. All right, it's going to be a minus, and I'm going to put this in parentheses so I don't mess up, because remember, you always have to distribute that negative. And when we distribute the negative, I'm running out of space here, we're going to get an x squared minus 6x minus 5x plus 20. That plus 20 will throw a lot of people off, so make sure you are aware of that. Over x minus 5 times x minus 4 times x minus 6. All right. When I combine these like terms, I get an x squared minus 11x plus 20 all over x minus 5 times x minus 4 times x minus 6. And so now my goal is to factor my numerator and determine if we have any common factors. So let's think about our numerator here. I have x squared minus 11x plus 20. And in order for me to factor that, I've got to find two numbers that multiply to give me 20, but add up to negative 11. All right, and if you think about that, no two numbers will work. And so this is actually done. All right. Let's look at one more example. Went a little too far there. We have x plus 2 over x squared plus x minus 20 plus 5 over x squared minus 5x minus 50. Again, we're going to factor our denominators. Have an x here, plus 5 minus 4. And here we have x minus 10 times x plus 5. All right, so this one gets a little complicated. I'm not sure if you can see it yet, but we will after a while. They have a common factor of x plus 5. And we also have an x minus 4 and an x minus 10 in each of those denominators as well. And so our goal is to rewrite these as equivalent fractions with the LCD in the denominator. X plus 5 times x minus 4 times x minus 10. So it's a lot to write. All right, when I look at these, this denominator has the x plus 5 and the x minus 4. It does not have the x plus 10, or x minus 10. So I'm going to have to take this x plus 2, and I'm going to have to multiply that by x minus 10. Okay? Similarly, this denominator here has the x plus 5 and the x minus 10. It does not have the x minus 4. So when I take that 5, I have to multiply it by the x minus 4. This is going to get a little complicated here. I'm just going to go ahead and distribute on both sides, even though that's an addition symbol. And it's not really going to matter. I could write them as 1 as we speak, but I'm just not going to do it. It's x squared. Now I'm going to do a little bit in my head, right? X times negative 10 is a negative 10x, but I have a 2 times x, that's 2x. So if I combine a negative 10x with a positive 2x, I get a negative 8x. 2 times negative 10 is negative 20 over x plus 5 times x minus 4 times x minus 10. And on the right-hand side of my, or the second rational expression, I get 5x minus 20. Now I'm at a good point to combine like terms. All right. And if you want to save paper or save some time, since this is an addition symbol, all you're going to be really doing is combining like terms. For instance, you have a negative 8x, and you're going to add the 5x to that, right? Because that's addition. And then you're going to have this negative 20 plus this negative 20 as well. That'll give you negative 40. And so what we're going to realize is that we're going to have x squared minus 3x minus 40 all over x plus 5 times x minus 4 times x minus 10. All right. I'm going to factor, right? So all of that work was getting the common denominator, getting me ready to add, and I've already added. Now the rest is just simplifying. Always leave your answer in simplest form. And so I'll factor x minus 8 times x plus 5 over my same denominator. By the way, that's a minus 4 there and a minus 10. And the x plus 5s cancel. Those are the only things that cancel. So our final answer will be x minus 8 over x minus 4 times x minus 10. And again, you don't necessarily need those parentheses around the x minus 8. Ruler doesn't matter, but that will be our final answer. This includes our study of addition and subtraction of rational expressions that have different denominators.